Hello people, I'm Bharat Acharya. Welcome to my video. Now, what are we doing today? We're doing 8051 programming. Finally, I know you've been requesting for so long and I've been wanting to do this, but it's just that there's so many other videos to be done. Anyway, so we're starting with this whole series of doing 8051 programs. This is the first video in which we're going to cover 7 programs. And then I'll make more videos. We've already done programs of individual theory topics like timer section, serial port and all. This is general programs which you're more likely to get in the practical exam. Okay, so you're going to start with a very simple program. This is a program to multiply 2 numbers. I'll be giving the full question of course, but I'm just giving you a list of questions. This is a program to divide 2 numbers, multiply, divide, obvious simple questions. Then program to add 2 numbers. Now when you do addition program, there is a complication of carry. So I'm going to teach you how to handle carry. Understand it properly, okay? Because carry is not something that will happen only in this program. 40 to 50% of programs that you do involve checking the carry flag for some reason or the other. The idea is the same always. I tell students in the class, I use this word a lot. You don't learn programs, you learn programming. You learn the skill of writing programs. So in this very simple question of add 2 numbers, I'm going to teach you the skill of handling carry, checking the carry flag and handling the carry. It's that same trick that we're going to use in at least 8-9 more programs wherever carry is involved. Okay, so once for all understand how to do it. Then we're going to see same addition of 2 numbers but with external RAM. Now when you do practicals in 8051, be careful about this point I'm talking. The same question when given to work on internal RAM and when the data is in external RAM, the solution is entirely different. When working with external RAM, there are lots of rules that have to be followed. So what are those rules? What are the complications because of that? Of course I'm going to teach you. This program will be a 6-7 line program. The same question, add 2 numbers but with external RAM with again some carry everything. That 7 line program will become a 20 line program or an 18 line program. Of course I won't remember the number of lines, but a very big program because of those complications. But again, what are you learning over here? How to deal with external RAM. Understand how to learn programming. You learn different aspects. So here you first of all understood how to handle carry. Now we go one step ahead and learn, understand how to work with external RAM. The rules that you have to follow while working with external RAM. Now those were basic operations, add, subtract, multiply, divide. If you know addition program, you know subtraction program. It's the same thing, instead of add you have to subtract. Then a typical exam question, block transfer program, transferring a block of data from one place to the other. At least in Bombay University, hot favorite. I'm sure whichever university you are in, this is asked a lot in practicals, also in theory paper. So this one is a simple block transfer from internal RAM to internal RAM. Then this one is from internal RAM to external RAM. Similarly, there is external RAM to internal RAM, which I'm not doing because once you know how to do internal to external, it's the same logic, it's just the direction will change. And then the most complicated of all of them, transferring a block of data from external RAM to external RAM. This requires serious skills. It's going to take this whole section, it's the biggest of all these programs, and that's going to require some serious skills of handling registers. There is a complication when you're working with external RAM. You want to work with 2 blocks of external RAM. There is a serious complication because there's only one pointer called DPTR. We'll come to that when I teach that program, you'll understand. So I'll be teaching you how to handle DPTR for 2 different locations, etc. Anyway, so that's the idea. That's what we're going to do in the video. Now, as usual, you know what I've been doing. This is an introduction. I just told you what we're going to do. You want to watch the whole video? Please come to my website or download our app. Our app is about to be released. I think by the time this video is out, the app will also be out. The app is on the Android store. Even if you're not using Android, if an Apple user, no problem, come on our website. If you don't want to use the app, you can come on the website. It's the same thing. Our website is called bharatacharyaeducation.com. On that website, you got to subscribe to the channel 𝗕𝗵𝗿𝗯. There is a small payment, but you got to pay that. I mean, this is a professional service. Of course, there's a fee to it because we are ourselves putting day and night on this in shooting, editing, uploading and managing all of this. So obviously there's a charge to it, but I've kept the charge very low. It's less than a pair of jeans. Come on. Anyway, so all you need to do is make that subscription and that's it. You can watch the videos for 6 months, unlimited number of times, all videos of 8051. There are already 30 plus videos in 8051. The only thing that was remaining was programming and one stepper motor interface. I think we'll be finishing that in a day or 2. Anyway, so you can watch all of those videos as many number of times as you like. And now this is what we've been doing for the last 6 months. But students, some of the students who do not have access to too much data because their internet plan, whatever they're using, they had this issue that every time you watch the video, it consumes a lot of data, because it will, because it's a video, which is obvious. So that's the reason why we come up with the app. In the app, you can download the video. So what you can do is, once you've downloaded, you can now watch it again and again from your own phone. A, you're not consuming data. B, you can watch it from places where you don't even get good internet connection. Suppose you're traveling from one city to the other, or whichever place you are in. If the internet connection is poor, you can't access the site, no problem. The video is there in your app. You can watch it as many times as you want to. Anyway, so, and plus one more thing in the app, just to tell you, we also have the notes of my book that I sell otherwise as a separate object. Sections of the book which are pertaining to that particular video. Let's say for example timer section, or let's say for example programming section. So this part which is there in the book will be available along with the video in the app. There will be just a separate button, you just have to hit that and you can see those pages of the book. And so what happens is, with theory topic, you have the whole theory answer with you. So you're not only understanding the topic from the video, you're also preparing it for the exam from the answer. People were texting me, sir, we don't have the right material. So in case those who could not for any reason order the book, I used to keep sending pictures of that particular topic, at least so that you have that much. So that's how I got the idea, why not just give this feature in the app. Putting all of this on the website was getting too tedious since you're making the app from scratch. So we had a platform to put all of these new features in it. So that's what the app is ready. It's going to be released on 20th March. If you're watching the video after that, the app is already there on the Android store, Google Play Store, whatever it's called. The name of the app is the name of the channel, Bharat Acharya Education. Okay, hope to see you there. So we begin. So this is our first programming question. Write a program, listen to the question carefully. Write a program to multiply the contents of location 20 and 21, store the result at 22 and 23. Simple. Write a program to multiply the contents of location 20 and 21. First of all, you tell me 20 and 21. These are addresses of which memory? Internal RAM, internal ROM, external RAM, external ROM. They have not given anything in the exam. What do you understand? Come on, you're intelligent. Everything doesn't have to be given in the exam. Because, first of all, because this is data, it has to be in RAM. You understand that much? ROM is program memory, RAM is data memory. You understand that, right? Now the question is whether it's internal RAM or external RAM. Because they've given addresses as 20, 21, 22, 23, that means they are 8-bit addresses. That means it is in internal RAM. External RAM has 16-bit addresses like 2000, 2001, etc. We'll be doing programs for those also. Right now we're doing it for internal RAM. Okay, this one to start with. Internal RAM is easier, so we're starting with that. Now, those were addresses. What about the data? This is the data of location 20. This is the data of location 21. What is the size of this data? What is our question? To multiply how many bit numbers? This is a program to multiply 8-bit numbers. Now, how did you understand from that? You want to multiply contents of location 20 and 21. One memory location always carries 1 byte. I have said this numerous times during earlier explanation of theory topics. One location always carries 1 byte. So location 20 and 21 means 8-bit and 8-bit numbers. So this is a simple program to multiply to 8-bit numbers. See, some examiners are very nice. They will give a very simple question, multiply two 8-bit numbers stored at 2021 of internal RAM. Some examiners don't give so much detail. If the question is multiply contents of 2021, you have to understand two things over here. First, this is internal RAM. Secondly, the numbers are 8-bit. Now tell me, my friend, when you multiply two 8-bit numbers, the answer is how many bits? 16 bits. You understand that 2 raised to 8 multiplied by 2 raised to 8 is 2 raised to 16. So when you multiply 8-bit numbers, suppose they are FF, worst case scenario, FF into FF is FE01, which means the answer is 16 bits, which means the answer will be stored in two locations. Do you understand that? Now, when it's stored in these two locations, 20 and 22 and 23, how will you store the answer? There is a principle followed. Lower byte, lower address, higher byte, higher address. Say it again. Lower byte, lower address, higher byte, higher address. This is 22, this is 23. Obviously, this is the lower address, so it will get the lower byte. 23 will get the higher byte. Please tell me, did you understand the question? Take the data of location 20 into A register. Take the data of location 21 into B register. Why? Because you intend to multiply them. Multiplication in 8051 happens only using one instruction, 𝗓𝗵. You want to multiply two registers, two numbers, they have to be in A and B registers. There is no other option. You can add A with a number, A with a register, A with the contents of a memory location. Add. You can subtract, blah blah blah. But multiply, divide only happens between A and B registers. Are you clear? So take the first number in A, take the second number in B, multiply the two. Answer will come in yes, B and A. A will have the lower byte, B will have the higher byte. Store the value of A, that is the lower byte, at location 22. Store the value of B at location 23. That is your program. Now what I always tell my students when I teach programming in the class. First, when you get this question in the exam, first make a sketch of what is happening. Get the idea on paper. Don't keep the idea in your mind, because then what happens when you're writing the program? Half your mind is confused about the logic, half your mind is struggling about the instructions. You make a mix of the two and you make a mess of programming, and you think programming is very tough. Programming is very easy. It's the easiest part of the subject, and I'm serious when I'm saying this. Let these 7 programs get over. Let me do a few more videos on programming and you will completely concur with what I'm saying. It's the easiest part of the subject. The problem is you got to do it right. Don't mix coding and logic both together. Keep logic separate, keep coding separate. First get the logic on paper. Now what do you have to do? Just write the instructions for doing this. Yes, you would argue, sir, this is a very simple program. But my friend, that's how you start. You start with simple programs, and before you realize, you end up writing very big programs. Your idea is first start with simple programs and start doing things in the correct way. So that's what we are doing. Come on. Take the data of location 20 into A. Come on, give me the instruction. Shabash, give me. I can do it 2 ways. I can write all the programs and explain. I never do that even in the class, because what's the point? Everything is there on the board, your mind doesn't work. I want to form this together with you, okay? So I need your participation. Try to speak it out. If anybody else is looking at you and thinking there's something wrong with you, who cares? Pay attention and understand this. This is just a one-time thing that you have to do. Focus here. Take the data of location 20 into A register. Move A, comma, what? Hash 20 or 20? Exactly, 20H. If you write hash 20, that means A is getting the data 20. We don't want the data 20. We don't want value 20. We want the contents of location 20. That means 20 is the address. We want data from that address. And if there is an address, you don't put a hash. You just write a number. Number with a hash is data. Number without a hash is address. You know that, right? You know addressing modes, right? So move A, comma 20. A gets the contents of 20. Now similarly, get the contents of 21 into B. Move B, comma 21H. B is an SFR. The assembler will substitute the address of B, that is 0F0. You don't have to do it. You can write B. The assembler will substitute the address. Some college teachers just have a habit of writing 0F0. That is not wrong. That is also fine. Even if you write this, it is fine. Assembler will anyways put 0F0 as the address of B. Anyway, it doesn't matter. So you've taken the first number in A, you've taken the second number in B. Now what do you want to do? You want to multiply them. Instruction. Mul AB. It's not mul A, comma B, okay? Mul AB. These are fine points which you only understand when you type instructions in the practicals. Now, I don't know whether you have the time remaining to do it or whether you have your practical exam the very next day, then learn it. If you type mul A, comma B, assembler will throw up an error. There is no such instruction. The instruction is called mul AB. Now, you have multiplied them. Answer has come in A and B registers. Answer is 16 bits. A has the lower byte, B has the higher byte. Store the value of A at 22. Come on, give me the instruction. Come on. From A register, store it at location 22. Come on. Move 22H. Good. Comma A. Excellent. Come on. Now from B, store it at 23. Come on. Come on. Come on. Move 23H, comma B. Job done. That is your program. Tell me, did you understand this? Now what do you do at the end of the program? You draw a line. Don't cross with that cross. No. See, a processor. Get this clear. Okay. A processor executes programs. Now, when the processor has finished executing this much, processor is not going to stop here. Processor is going to go ahead and start doing other things. And when the processor does other things, the value of everything else will change. So, including, for all you know, the value of those locations will change. So, how will the examiner come and check your result? Because the values have changed. So, what you need to do is stop the processor over here. How do you stop the processor? By writing halt? No, there is no halt instruction in 8051 at all. Then, how do you stop the processor? By writing the instruction S jump. What is S jump? Short jump. You know that, right? Which is basically jump over here. Short, long and absolute is just the distance. The idea is it's a jump. Jump to the location here. What is here? Here is a label. Where do you put it? Here only. Jump back to the same location. Now what happens? Processor did this, job done. It will do jump here, we'll come back over here, then again jump here, then jump here, then jump here, then jump here. So the processor has gone into an infinite loop. The point is the processor has stopped here, it's not doing anything else. That means these values will remain in these registers, and whenever the examiner wants, he and she can come and check them, because that's what they want to do. When your practicals are over, they come and check the values of the registers. So the processor starts doing random things, everything else will change. You have to stop the processor. To stop the processor, you write sjump here. Some college teachers write return, nothing wrong with that. If you're writing return, that means you're using this as a subroutine. That means it will return back to the main program and do what over there? Sjump here. So that return will also eventually do sjump here. Some college teachers write end over here. Now if you've seen the instruction set, we have done 111 instructions of 8050 on the whole instruction set. There is no instruction by the name end. What is end? End is an assembler directive. Say this word again. Assembler directive. That means it's for the assembler. When you write end, you're telling the assembler substitute this with sjump here or return, whichever way the assembler is designed to do it. The point is, if you write end, it will be substituted with sjump here. If you write return, it will go back to some place which will eventually do sjump here. The idea is to stop the processor from going ahead. Stop there. Just 1 second, I will get my phone and I'll show you something. 1 second. Okay. So for example, on the phone, all these apps are various programs. You understand that, right? They represent different programs, application programs. So say for example, I call someone and I'm dialing someone. So I'm speaking to somebody. What is that? Is that a program? Yes. Like this, even that is a program. Now my conversation is going on. Great. Now it's over. The program is over. What happens now? What is the phone doing? Come on, my friend, answer. What is the phone doing right now? Is it calling other people? No. Is it reading my messages? No. Is it seeing my pictures, watching my videos? No. Is it playing a new game that I downloaded, some chess game or something? No. Then what is it doing? Is the phone off or on? It is very much on. Then what is it doing? A layman says it is doing nothing. That is a layman. You are much more than a layman. You're going to become a techie. Please stop saying stupid things like it's doing nothing. A processor cannot do nothing. If a processor is on, it has to execute instructions. So what is it doing? It is just waiting. How? By doing sjump here. The processor is looping on one instruction, waiting. When will this loop break? When I tap the screen. What happens when you tap the screen? You open a new icon. That means a new application. It will run. So it will get an interrupt, go into that application. Do the application, done. Come back. Now what? Again, it's going to wait over here. You click on another screen, again. That means you tap something else, you're given an interrupt, will do another application, come back, it's again back to the home screen. Please tell me, do you understand? It's doing as of now sjump here. Yes. After some time, when the processor realizes that sjump here is happening for a long time and there is nothing productive going on, then the processor, because that also consumes power, it's as good as doing any program. This is as good as doing anything else. It's still consuming power. sjump here is an instruction which has to be fetched, decoded and executed. So power consumption is almost the same. Processor will slowly start dimming the light because it realizes there is nothing useful happening, and within no time will go into a sleep mode. I just activated by pressing the button because I won't wait for that long, but you got my idea. Now if the processor is in sleep mode, this is power saving mode. So I'm going to do a video of this. This is very interesting in 8051. But before that, it was not in that. Now when I click on this, right now what is it doing? It has displayed. Yeah, students say it is displaying. No, it is not displaying. The processor has displayed. Processor has sent it to the display is displaying. What is the processor doing? It will not keep sending this again and again. It has sent it once. Now the processor is doing sjump here, and then again with no action happening, will go into sleep or will get a call and wake up and again do whatever it has to do. So I think I made my point clear. So we end our programs by writing an instruction which jumps back to the same location, or if your college teacher is writing return, no problem. But as a student, when you're curious, you think when it says return, where does it return? Returns back to a location where it is written, where somebody has written sjump here. So that it keeps looping back at that same spot. Are you clear? Now, that is the first program to multiply two numbers. We go ahead. The next question. Write a program to divide. We did multiplication, now we're doing division. I'm changing the question a little bit. I don't want to keep it monotonous, divide the contents of 2021. Then what will happen? It will be the same program. All I'll be doing is substituting multiply with divide. No. So I'm changing the question. Listen to the question properly. So guess what we just finished doing? We finished the whole video actually. We've done this video on 8051 programming. We started with a very simple program to multiply two numbers from internal RAM. Then we got into division. Then we did a program to add two numbers which also involves carry. There was an internal RAM. Then we saw all the complications that happen if the same question is asked for external RAM. This is addition in internal RAM. This is addition in external RAM. You see there's a big difference in the program. Then we started doing block transfer programs, the most frequently asked program types. So this is internal RAM to internal RAM to external RAM. External to internal is pretty much the same. Then the big one, external RAM to external RAM, which has this whole big sequence because of the complication that there is only one pointer, that is DPTR. Anyway, so we did all these programs. It was fun doing it. I hope you enjoyed learning it also. Okay, wish you all the best. Do well. See you there.